Hi, my name is Glowscript and this is my lab report for the magnetic field of a bar magnet. The contents of this lab report include the introduction, measurement and calculations, and the Glowscript model. This experiment involves looking at the magnetic field induced by a bar magnet and visualizing it through code. The main physics principle used in this lab is the Biot-Savart law, which identifies the relationship between distance and the magnitude of a magnetic field. The formulas are located below. The results state that n, the distance dependence of the magnet, is negative 3.0907 meters, and the magnetic dipole moment is 2.38 amperes times meter squared. This diagram demonstrates the experimental model. The first involves placing the phone on axis to the magnet, and the second is at a 45-degree angle to measure the magnetic field induced by the magnet. The phone was first directed at magnetic north in an effort to create a zero value for the x component of the readings for this lab without the magnet. The data for the on-axis is on the left, and that was linearized and plotted according to the Biot-Savart law, and the op-axis data was used to compare with the Glowscript model. The linearized model shows the natural log of the magnetic field as a function of n, the distance dependence, times the natural log of the distance added to the natural log of k. The observations made during the experiment are that when the magnetometer is far away from the magnet, the x-direction value is near zero. Additionally, when the magnetometer is moved closer to the x component of the magnetic field increases. The magnetic field of Earth had to be subtracted from the y and z values in order to isolate the magnetic field of the bar magnet. This was not done with the x component since it started at zero. The graph depicted the Biot-Savart law in the form shown. The n value was the slope at negative 3.0907 meters, and k was calculated to be 4.75 times 10 to the negative 7th. Setting the distance-dependent equation equal to the Biot-Savart law led to the calculation of the magnetic dipole moment at 2.377 amperes times meter squared. These are the main parts of the Glowscript model, including the function that calculates the magnetic field, and this allowed for the creation of the magnetic field of a dipole at any location. There were 6 locations added, 2 on axis and 4 perpendicular added to create the observation locations of the lab. They are represented by r-axis and r-perp. The magnitude and observation location 45 degrees from the axis were calculated by using the d-perp value and input through the dipole function to obtain the magnetic field value for this location. The orange arrows show the on-axis field, and the cyan arrows show the 4 perpendicular fields, with the purple arrow being the 45-degree angle field. As you can see, the magnitude for B at 45 degrees was 2.8756 times 10 to the negative 5th according to the Glowscript model, but it was measured to be 5.67 times 10 to the negative 5th in the data. This variation is understood, and the fact that they are within the same power to the 10th shows that the data was mostly accurate for the lab, but there is always room for improvement. A few questions raised here are that, if the setup did not compensate for magnetic north, what would happen? The Earth's magnetic field would interfere with the reading for the bar magnet, and the data would not be accurate. Additionally, adding an identical magnet attached to the first would just increase the magnitude of the magnetic field. It may not double, but it would definitely increase. In conclusion, the results of this experiment were obtained by the Biot-Savart law to calculate the distance dependence and the magnetic dipole moment. An error that could have occurred was appliances used near the magnet that produced a magnetic field that would interfere with the radar, and performing it in a more remote location would have benefited it. Thank you for watching.